problems that we did speak about up until now have solutions in the literature of mathematical logic. There are decidable languages, there are solutions. But there is one big problem that has no solution, and we had to invent a solution. And the problem is a language that can speak about truth of other sentences in the language. Logicians proved that in a certain form, such a language cannot be consistent. It must contain a contradiction. This is called Tarski's Undefinability of truth. But there is a serious real-life need in being able to do so. We needed to find a way to have maybe a more limited setting, not exactly the setting that Tarski considered, but still allowing us to speak about truth of other sentences. And this, we can relate it to maybe 3 examples: to blockchain, to AI, and to real-world law. So we spoke about blockchain that is controlled by its users, taking it more down to earth. So in each block, you are going to have the code of the network itself, a definition of what the network should do. The whole point in blockchain is a condition of accepting or rejecting a proposed block. For example, in proof of work, you accept it if the hash satisfies certain conditions. But if the block contains statement of the network itself, and the current network needs to speak about those statements, ask questions about those statements, all in the same language, otherwise you're going to need infinitely many languages, and get an answer. So that's a blockchain example. Take an AI example. There are the 3 laws of robotics by Asimov, that a robot will never harm humans and so on. I say that you need a 4th law of robotics, which is any future software update of the robot will also admit the laws of robotics. You don't want to plug in a USB key to the robot with software update, then it starts killing people. You want the robot to reject this update if it does not admit the laws of robotics. This is the same problem that the current field of mathematical logic cannot handle. The update is written in the same language that the robot is written, and you need the same language to ask whether another statement in that language is consistent with another statement being the laws of robotics. The 3rd example, the law of changing the law. You have law, all right. Now you also need laws of changing the laws, because if you don't have laws of changing the laws, then either you cannot change the law, or there are no conditions of changing the law. The law is meaningless. You can always change it. So you need laws of changing the laws. But then you are going to need laws of changing the laws of changing the laws. Because if you don't have laws of changing the laws, then you cannot change the law of changing the law, and so on. So you are going to need infinitely many laws just to begin with. What are you going to do? Well, you need the laws of changing the laws to refer also to themselves. For example, imagine a constitution that says, if a proposed law contradicts the constitution, then it needs 60% majority. Otherwise, it needs 50% majority. Those 3 examples are all about the same thing. Language that can speak about truth and contradiction of its own sentences. And this was our biggest theoretical effort, and we achieved that. And then we had to move on to the second theoretical effort, which is, after we achieved that, this language has to be able to be a software specification language, because we are all about software controlled by its users, blockchain controlled by its users. Software specification languages are characterized by having a temporal dimension. The first do this, then do that. So it took us another quiet way to turn this language into a software specification language, but we achieved that as well.
That is something you have actually achieved and is ready or nearly ready, correct?
Yes, it is ready on paper. We are now implementing it. Luckily, we don't need to implement it from scratch because we already implemented maybe all the machinery necessary to implement this language. And hopefully in the next month, we can see it running.